Hi, in this video we're going to take a look at the second type of quantities we encounter in physics course. These are vector quantities. In the image at the bottom of the screen you can see an arrow representing a force of 5 newtons at 45 degrees to the horizontal line. And this is how we normally show vectors in the diagrams. Vectors are arrows. Vectors have magnitude and the direction. And this is how we're going to define a vector. A vector quantity is one with both magnitude and direction. And there are a number of vector quantities that we're going to encounter in the physics course. So let's have a look at some of them. We have the displacement, we have velocity, acceleration, momentum, force, and so on. So we're going to encounter those over the next videos. And let's take a look at the first one of them, which is the displacement. So we're going to define displacement as a distance in a given direction. And it's best understood while looking at a diagram. So here in the diagram, I have 2 points, A and B, or start and end. And those 2 points represent the start of a curved path and the end of a curved path. And I also have a straight line connecting the start and the end point of that curved path. So the length of the curved path is the distance we would have to travel by moving from A to B. Whereas displacement is a straight line connecting the start and the end point. The displacement can be thought of as how a crow would fly from the start point to the end point of that journey. And we're going to add that displacement is a vector quantity because it does have a size and it has to have a direction. And we're going to say that it's a vector quantity with an SI unit of 1 meter. Now, let's take a look what happens when we take displacement and combine it with time. We're going to introduce a quantity called velocity. So velocity is defined as the rate of change of displacement. So if displacement changes, depending on how quickly it changes, we can talk about velocity of an object. We're going to add the relationship between the displacement and time to be able to calculate velocity. So velocity equals to displacement over time. And you can notice that this formula is exactly the same as the formula for the speed. However, here we have to be very careful because the letter S represents the displacement from the origin, not the distance from the origin. We can also again add that the velocity is a vector quantity with an SI unit of a meter per second. Very similar to speed, but again, we have to be cognizant of the subtle differences. The S represents the distance, the displacement, not the distance for calculating velocity. And let's add that in many of our calculations, we have to deal with starting velocities and ending velocities. So we're going to refer to initial velocity always using letter U, and we're going to refer to final velocity using letter V. The initial velocity happens at the start of the motion of an object, and the final velocity V occurs at the end of the motion of the object. And just as a side note, if the object has a constant acceleration, we can find the average velocity for that object while it's accelerating from some initial velocity to the final velocity by taking the sum of those two, taking the sum of initial and final velocities and dividing those two values by 2. Okay, so let's see how it applies to a problem. First, we have a man who walks 4 meters east and then 3 meters north. We have to find the distance he traveled, and then we have to find the displacement he traveled from his original position. So now, pause the video, and I will provide the solution in just a second. Okay, usually in physics problems, diagrams help. So let's represent the motion of this person using a diagram. So this line will represent the traveling east, and this line will represent traveling north. So we can see that the person travels 4 meters eastwards and then 3 meters northwards. So the total distance is a simple sum of those two values. So that's 4 plus 7 equals to 4 plus 3 rather equals to 7 meters. Nevertheless, however, we have to remember that the displacement is along a straight line from the starting to the end point. So I just represented displacement, and that should, now you should see that this completes a right angle triangle. And in the right angle triangle, the Pythagoras' law applies, so we can say that displacement squared is going to be equal to 4 squared plus 3 squared, which is the same as 16 plus 9, which is 25. So from here I can get that displacement will be equal to root 25, and that's 5 meters. Okay, next let's take a look at this problem. A body travels 80 meters west in 20 seconds. What is its velocity? So as always, I'm going to try to model how I solve the problems. So I always write down what quantities do I know. So I know S equals to 80, and I know that T equals to 20. And I know that I'm looking for velocity, and the formula for velocity equals to S over T. So now I can substitute the values. V equals to S over T equals to 80 over 20, and that equals to 4 meters per second. Okay. The last thing that I'm going to talk about this when I'm talking about the solutions, it's really good practice to solve your problems like this. And just as an examiner's tip, please make sure to write those values and the formulas around, because the examiner will reward you for taking the formulas down if they are relevant to a given problem. Okay, so then in the next problem, we're going to take a look at addition of vectors.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.